We'll start in just a moment. I'm just getting us live on YouTube right now. Okay. Sorry, it takes a moment. All right. I'm going to go ahead and start the recording and we'll get going. All right, thank you everyone for joining us for this free webinar, Fundamentals of Aggregate Surface Trails. My name is Candace Gallagher and I am the Director of Operations and Webinar Coordinator for American Trails. This is our 260th webinar in the American Trails Advancing Trails webinar series, and this is the second of 3 webinars in a series that we are hosting this fall and winter in partnership with the Professional Trail Builders Association. And this webinar is being recorded. It includes real-time closed captioning in English and also offers free learning credits, and you will see a link to the quiz and the survey in the chat box. And you can also turn on captions by clicking on the CC button at the bottom of your Zoom window. And if another language is ever needed, please just let us know. Attendees will receive a follow-up email from me within 2 days post-webinar that will include a link to the recording, the transcript, resources slide that will include the presenter's emails as well as learning credit details. And would you consider donating to American Trails to help keep these webinars produced weekly and free to everyone? I invite you to visit americantrails.org/join for membership and donation options and help us reach our goal of 500 new members before the end of the year. And I want to thank our webinar partners, additional webinar partners that include Washington's Evergreen Coast, iZone Imaging, 5280 Creative, the Bureau of Land Management, the National Park Service, the USDA Forest Service, as well as the Grisberger Fund. And the Grisberger Fund is a donor-advised fund that belongs to 2 regular working people who really love trails, and they encourage everyone to learn more about donor-advised funds and how you can use them to increase support of American Trails and the free education that we provide. And I'm happy to introduce our presenters for today. We have Jed Talbot, who's the owner with OBP Trailworks. And we also have Aaron Amadon, who's the owner with Town for Trail Services. But before I pass it off to Jed, I'm going to hand it over to Aaron Kay, who's the Executive Director of the Professional Trail Builders Association.
Thanks, Candace. We're excited to offer another webinar as part of our series this year. I just wanted to give a little bit about PTBA. So as the trade association for the trail industry, PTBA represents private sector member companies who have joined together to advance the trail industry by promoting quality and professionalism. Each PTBA member company has been professionally vetted through a rigorous portfolio submission and peer review process. Next slide, please. And we're all over the world. So we have 134 member companies currently, and that's with about 2,000 employees. We're worldwide, and as you can see, most members are currently in North America, but we're definitely growing throughout the world. Next slide. And I just wanted to share this slide because it captures our 2023 impact of our member companies. And just, it's obvious, our companies are on the trail full time. And you can tell by the numbers, the miles of trail built and designed and kind of all the statistics on this slide. But now I'm pleased to introduce Aaron Amadon of Town for Trail Services and Jed Talbot of OBP Trailworks. Thank you both for sharing your expertise and decades of experience in this webinar and for all your work with PTBA.
Thanks, Aaron. All right. So here we have, I'll start it off and then I'll pass it off to Aaron shortly. Thanks everybody for coming. This is, as we hopefully expected, Fundamentals of Aggregate Surface Trails. My name is Jed Talbot and my company is OBP Trailworks. We're a design and construction company based in Maine. We do everything trail related except for very specific bike projects. We specialize in technical stonework on trails, structures like remote bridges, boardwalks, staircases, that sort of thing, and increasingly aggregate surface trails, particularly a lot of multi-use and accessible trails. And we really like building them in challenging terrain. So we're going to talk a little bit about that today. Erin will introduce herself. But as a background, Erin and I have worked together in various capacities for over 20 years. Although we have separate companies, we were once part of the same company, and we still frequently collaborate on projects here in the Northeast. Go for it, Erin.
Oh, thanks, Jed. Can you start sharing the presentation for me, please?
Oh, I'm sorry. Are we not seeing? Is it not?
It is
on?
showing.
Oh, okay. Maybe I'm just not seeing the slides then. Right now, I just see the slide of questions with our contact information, which I think is the last slide.
I think on the top, Erin, you can click Jed Talbot's screen. So there's Candace and then Jed. Do you see that?
Oh, no, I apologize. So I will just wing it.
I'm so
Oh,
sorry.
there we go. I got it.
Share.
I got it.
Sorry about that.
No, that's okay. I got it now.
Zoom updates. I'm so sorry.
No, thanks, Candace. Well, thank you, Jed. Thank you, Candace. Thank you, Erin. I'm Erin Amadon, owner of Town 4 Trail Services. I am based in Maine. My company is committed to designing and constructing sustainable natural surface trails. We focus on time-honored conservation work, and we support the next generation through training and education. Next slide, please. Welcome everyone to our webinar on aggregate surface for trails. Today we'll explore the importance of these surfaces, the various types, key design factors, best practices for construction and maintenance. We'll also share some of our practical examples and wrap up with a question and answer session. There's a lot to cover, so I'm going to get started. In this webinar, we'll look at different types of materials used for trail surfaces, their applications. We'll also talk about how things like slope, soil, drainage matter when designing trails. Plus, we'll share tips for moving materials efficiently and explain why compaction is so important to ensure trail durability. So first, let's define what we mean by aggregate. So essentially, an aggregate refers to a granular material like sand, gravel, and crushed stone. These materials have a wide range of uses for trail construction. They can enhance tread durability by providing a firm and stable surface. They help resist erosion, reduce maintenance, and provide resilient surfaces that can reduce wear. They can reduce environmental impact by minimizing soil erosion, manage water runoff effectively, and prevent sedimentation. They can improve user experience by offering a smoother, more predictable path of travel, reducing some of those tripping hazards, and provide a comfortable experience for users. Aggregate surfaces can play a critical role in creating a firm and stable surface to meet accessibility needs and standards. Aggregate materials can be chosen to complement the local environment, ensuring trails maintain that natural appearance. You may be somewhat limited on coloration based on the parent material, availability, and pit locations, but typically you are sourcing that material as close to the job site as possible. If installed properly and with the appropriate sized aggregate, these trails can withstand diverse weather. These materials can allow for adequate drainage, resist formations of ruts, puddles, and mud. However, we should acknowledge that there is some limitations to what they can withstand. Next slide, please. There are different types of aggregates used in general construction. Each type is used for a specific purpose and depending on its properties for the need of the project. We should mention that there are manufactured aggregates because sometimes they're used in conjunction with other aggregates, but it's not going to be the main focus of our discussion today. There are recycled aggregates out there, and using recycled aggregates can help to minimize the environmental footprint by reducing raw material extraction and create a durable surface. Natural aggregates are unprocessed. They come straight from the earth without significant alteration. So for example, you have like your bank run, which is mix of sand, gravel, and stone. It's naturally deposited by rivers, often used as is for foundational support. Sand is generally mixed in with other aggregates and it's not typically used as a tread surface. River stone is known for its round edges, its aesthetic appeal. It's often used in landscaping or for decorative finishes on the trail. Typically, we don't use that structurally. Unscreened gravel has not been processed to separate by particle size. This type of gravel is often used as a basic fill for foundational layers where precise particle size is less critical. And then screened gravel has been processed to separate particles by ensuring uniformity and consistency. Oftentimes, we'll take those unscreened gravel. Sorry. Thanks, Jen. Oftentimes, we'll take that unscreened gravel from a borrow pit and then transport it to our trail where needed. Typically, this is done, by 5-gallon bucket or dirt bags or equipment. While this can be an essential part of a trail project, sometimes cost-effective, it's not really going to be the primary focus of our discussion, but I wanted to make sure that we mentioned it and acknowledged that its use in trails. All right, we're going to mainly focus on crushed aggregates. So crushed aggregates are made from larger stone or blasted from ledge that has been mechanically broken down into smaller angular pieces. The angular edges of the crushed aggregate locks together, and this can enhance its strength, resist movement, and help maintain durability over time. This is just a general list. Every time you call a quarry, they're going to have a different name for the same product. So to ensure that you're getting a consistent product and you're really getting what you want, you can ask for that gradation test report or the sieve analysis. So that sieve analysis is basically a method to determine the distribution of particle sizes in a sample of aggregate. So basically that aggregate gets passed through a series of sieves with progressively smaller screen size. And then the material that's retained is weighed and calculated to the percentages of that total sample that it represents. When you order material from a quarry, you're either going to order it by the yard or the ton, and it's priced the same way, but it typically doesn't include trucking costs, so you want to take that into consideration. Here are two different examples of different sieve analysis that have worked well for accessible trail applications in the past, because it has what I think at least has the proper ratio of larger particle sizes to fines in order to achieve that optimal compaction, stability, and surface drainage. When you're choosing an aggregate, it's important to consider things like its grading, its durability, the particle size, the surface texture, abrasion and skid resistance, as well as absorption and surface moisture capacities. Hold there for a second, Jen. One of the most important sustainable trail layout principles is how we address slope and grades to manage water effectively. We all know this, right? A steeper slope generally leads to increased erosion and aggregate breakdown, meaning that on a steeper slope, the aggregate surfacing material is more likely to be washed away due to the increase of water flow and force, requiring a design that better stabilizes the aggregate to help prevent erosion. Essentially, the steeper the slope, the more critical the design and quality of the aggregate surfacing becomes to maintain stability. One of the ways that we can ensure that we don't have too steep of a slope is by following that half rule in our design phase. So basically, this means that the trail grade should never be more than half the slope of the hillside. Another way we can look at that is thinking about trail slope alignment. Thanks, Ted. So trail slope alignment can help us lead to a deeper understanding of how different slope alignments can affect trail durability and erosion. Aggregate size and surface texture play a critical role in trail stability. Larger aggregate sizes are more resistant to erosion as they lock together better and stay in place. But on the other hand, smaller particles are more easily washed away by fast moving water. Additionally, the surface texture of the aggregate matters. Rough textured particles create more friction. They help slow water down and reduce risk of erosion. But it's really that well-balanced mix of particle size and that rough texture that can significantly enhance trail durability. In areas with steeper slopes, aggregate surfacing can be used to stabilize the terrain and protect against erosion, often combined with other stabilization techniques though. So mechanical wear happens from the interaction of how people use the trail and the trail surface itself. So the more traffic, faster speeds, braking, turning, heavier surface to contact area, sudden grade changes, improper drainage, and wind a trail gets, the more wear and tear you'll see. Using an aggregate material can help reduce this mechanical wear. Proper drainage structures, so your grade reversals, your grade dips, your outsloping treadway, your subterranean drainage are all essential to help control the water flow and prevent excessive erosion. Other design factors to keep in mind are like your canopy cover, water dripping off of tree branches or kiosk roofs can add to wear and tear on the trail and should be considered when you're using an aggregate material. And compaction at the right moisture level is critical. Too wet or too dry can lead to erosion and maintenance issues. And I know Jed will touch on this when we talk about the construction methodology section. All right, so soil conditions. So first, it's important to note that I'm not a geotechnical engineer, but I am happy to share what I've picked up here and there with a lot of trial and error over 27 years of trail building experience. There is a lot of good information online about like design loads, subgrade bearing capacity, load positioning for trails, and that some of that information will be listed in the last slide. Secondly, I wanted to give a shout out to the previous webinar, basic soil mechanics for trail building with Alex Mann. Building off of that information, we're thinking about soil properties, things like texture and structure can really affect how well that aggregate sticks to the ground underneath. If the soil isn't stable or well structured, it can impact the overall stability of the trail. And so one of our considerations in soil conditions is that hillside hydrology, where that water table is and how that water moves through the landscape are important factors into successful aggregate installation. Properly accounting for your design load can ensure that the trail can handle the intended use without degrading too quickly. So design factors would include things like user, the frequency, and other environmental conditions. And then you have your aggregate layering system, and we'll start with the top and work our way to the bottom. So your surface course is going to carry the load and provides the finished tread for the user. Your aggregate base is a supporting layer for the surface course. The thickness really is dependent on the applied stress and the bearing capacity of the subgrade. The subbase can be used to raise the elevation of the treadway, so to meet like your grade requirements or to fill in a slope, you're trying to reduce that, or to accommodate some of that subterranean drainage. And then your existing subgrade is that existing soil once you've excavated all that organic material down to your required depths. Oftentimes, a non-woven geotextile fabric can be used to increase soil stability and prevent fines from moving between the layers, both up and down. Next slide, please. Thanks. So first and foremost, we want to maintain that natural drainage through our layout and design process. And then we want to make sure that we're building a trail on a side slope to help maintain that sheet flow, allowing that water to move evenly across the surface. And then we want to make sure that we are outsloping or crowning the tread to allow for that surface water to flow off the trail. Most importantly is that subsurface drainage. It is key to maintaining that natural drainage of that hillside hydrology through that landscape. Oftentimes, this can be done by like a rock sandwich, a burrito, or a lasagna construction method. We like our food references in the trail world. So like a rock sandwich is usually like sometimes fabric, depending on your sub base, and then like a 2-inch angular stone, compacted fabric, base, and then your surface course. And the type of use on the aggregate trail has a big impact on its condition. For example, heavily used trails can experience more wear and more compaction, while foot traffic tends to be less of an impact. The more intense the use, the more frequent maintenance may be needed. Aggregate materials, especially when properly compacted, help distribute the weight and reduce erosion, making them ideal for trails that see a lot of foot, bike, and horse traffic. It's important to note that aggregate surfaces can be significantly affected by season abuse, such as weather conditions like rain, freeze-thaw cycles. High temperatures can alter the material stability and durability. However, using an aggregate surfacing can still be beneficial due to its cost effectiveness, ability to manage water, and flexibility in various climates. And then last but not least, before I hand it over to Jed, is that linear grades and cross slopes are still important factors to ensure that proper drainage and trail stability, which we had mentioned earlier.
All right. Thanks, Aaron. I'm going to talk for the next 20 or so slides about the construction process. The idea is by presenting the proper techniques and showing the construction sequence of a typical multi-use aggregate surface trail, a lot of the questions about what to do and what not to do will kind of be covered. So, equipment. Although it's possible to build, aggregate surface trails with simply like an ATV and a dump trailer, having the most appropriate equipment makes a huge difference. We generally use track machines that are no wider than the finished tread and sometimes considerably narrower than the finished tread, except for some, occasionally some compactors and some wheeled loaders. Without going too deeply into the specifics, because this really isn't a mechanized webinar, we use mini skid steers for grading, the larger skid steers for loading, tracked carriers of various sizes for hauling and dumping, getting that stuff way back out into the woods sometimes, and drum and plate rollers for compacting. We'll talk about those more a little bit later. We also use excavators for, believe it or not, excavating. And it's not uncommon to have, as many machines on a project as we have members, or dogs or kids. So the construction process. First thing we do, I'm going to skip over the design and layout elements for the sake of time, and assume that the trail has been marked out according to some of the design guidelines that Aaron was outlining earlier. The first step is to prepare the trail bed. Do that by clearing the corridor and removing as much vegetation as possible prior to the excavation. We usually blow or rake the leaf litter outside of the excavation zone, and pile it or windrow it kind of neatly so that we can reuse that again in the soil stabilization and the naturalization phase after, one of the last things we do before finishing a trail. So sometimes when we're building through fields or areas with like a solid vegetative root mat, we'll use a power box rake, often referred to as a Harley rake, to masticate the soil and churn it up into a nice loamy mix. So that makes everything a lot cleaner, keeps the seed source in the organic on the edges of the trail. You can also use a rototiller, but we find that a power box rake works really, really well. Then we start the excavation process, where we excavate to the depth of the finished trail tread and remove the organics. As neatly as possible, remove the organic layer, paying close attention to a bunch of things. Like we're looking at grades, the final elevation of the trail. So sometimes you'll see we'll have People will put grade stakes with elevations on them during this or directly after this this process. We're looking at the depth of excavation, where the organic layer meets the mineral soil layer, and also hydrology. We should be thinking about how the tread will shed water, generally either crowned, insloped, or outsloped, and visualize where the water is going to be going and how we'll be moving as it comes onto the trail bed and as it exits the trail bed during the excavation process. You really want to wrap your head around how you're going to manage the water as you're excavating the trail, and then that continues throughout the rest of the processes. So generally, we try to utilize the every stick, leaf, and blade of grass. Everything's a resource, and we use it as much as possible. But sometimes there's an excess of excavated organic material, rocks, or really commonly for us in the Northeast, it's rocks and stumps. We're digging up way more of those than we can reuse. They're a little bit unsightly, so we don't just throw them off to the side, generally speaking, but we haul them out of the immediate view shed of the trail. And sometimes they're dispersed or piled on site, and sometimes they end up getting hauled off. But it does take a considerable amount of time sometimes to remove the organic material from the trail bed, but it's not a step that we forego. Then we start to analyze and construct our water relief structures. So water relief structures include rolling grade dips, grade reversals, culverts, boardwalks, swales, etc. They should all be planned out while you're excavating the tread. The variety of water relief structures is considerable and varies according to the type of trail and the user. For instance, this photo on the left of the screen shows where we armored a rolling grade dip with larger screened aggregate that was taken from the site, because there's a lot of water that pours down this particular hillside to the trail, especially after a large logging cut was made higher up in the trail watershed. So you can actually see in the background, there's a few more of these rolling grade dips that are all armored with larger aggregate. Crushed aggregate would have been preferable to the round rock that you see, but we're maximizing on-site materials, using as much native material as possible. And there was a gravel pit and a screen on site. So that's why we have rounder rock in this particular photo. The user groups for this trail, just so you know, the one on the left are equestrians, Nordic skiers, snowmobilers, bikers, and some hikers, but it gets a lot of wintertime use. The photo on the right shows a wooden box culvert, which acts similarly to a traditional culvert with significantly less soil disturbance. You don't have to excavate the inlets and the outlets nearly as much, which we'll see in some later photos. I like this photo because it shows how we were able to capture the water via an uphill ditch to the right and behind in the background of the bridge. And we funnel it gently to the bridge that actually has a lot of riprap under it. This site's at a school, and there's a large field off screen to the right that all drains down to this area towards the retention pond. And so it's all guided to the ditch. The riprap serves to slow the water down and have it drop its sediment before it goes under the bridge and gets out to the pond. So this is the type of stuff we really want to consider before we actually start throwing gravel on the ground. We also utilize traditional double wall plastic culverts at times. When we do, it's important to sculpt the inlet and the outlet to channel water to the culvert with off-trail ditches and swales, and slow the water down after it leaves the culvert, either with riprap or large woody debris or level spreader, sediment pools. There's a number of ways to slow that water down after it leaves your culvert. The wing walls around the culvert should be retained with rock or timber, and a cap should be placed over the culvert with a minimum of 12 inches of cover. We like to hide our culverts from view with well-placed stones for aesthetic reasons. It's not as necessarily functional, but it really, I personally appreciate hiding those plastic culverts as much as possible on a trail. Then we have to identify and fill the sub-base areas. The sub-base, like Aaron was talking about on a previous slide, I'm loosely, calling sub-base. I'm referring to like drainage stone, whether it's crushed or screened. that allows water to pass through the trail. So we often use 1.5 inch stone, which is what you see in the photos here. But sometimes it's 3/4 inch rock, and sometimes larger aggregate. Sometimes we'll have 3 or 4 or 5 different sizes of aggregate that we're using in different places, depending on the need. If subbase is being installed over saturated soils, we should put geotextile fabric down underneath that stone. Fabric is always placed on top of the stone. We'll talk about that a little bit more in a minute. And as Aaron referred to that as a rock sandwich. Exactly where and when to install subbase and where it's needed and where you don't need to install it is kind of difficult to generalize. But as a point, we always install a subbase of drainage stone over anywhere where there's exposed ledge. Without a doubt, or bedrock, because groundwater, generally percolates until it comes down and hits that ledge, and then it moves on the top of that ledge. And if you're excavating your trail down to the ledge, the water is it'll easily wash out gravel really quickly if you don't give it a way to pass underneath your trail. And that can be done with subbase, but we usually also augment that with some other drainage features like culverts, box culverts, short little boardwalks, and bridges. So in terms of geotextile fabric, we use geotextiles between our subbase and our base layers. We don't often use them between our base and our surfacing layer, but sometimes there's a reason to. We prefer to use for trails a non-woven fabric, which means it's perforated, like needle punched, not like the plastic type you see on roads. It resembles like felt. And we usually use the 4-ounce weight. The manufacturer that we prefer to use, or the standard we like to use, is Merafi 140N, 140N, or equivalent. That's the specification we like. And geotextiles are really important because they serve 3 main functions. They act as a filter, a separator, and a stabilizer. As a filter, it allows water to pass through, but not sediment. Really important. As a separator, it keeps soil and aggregate of different types from mixing. If your subbase drainage stone is getting clogged with fines, it will cease to function. So it's really important. As a stabilizer, it gives more structural integrity to the soils and the surrounding aggregates around it. One thing that we don't really often talk about with geotextile fabric, but it also serves to a degree as a weed barrier. And sometimes that can be really important when you're building trails, like the environment we're seeing in this photo through fields. But enough about geotextiles for a minute. Let's talk about filling our trails. We fill our aggregate surface trails, our base, in lifts. Lifts or layers. So in order to achieve adequate compaction rates, we want to have the thickness of each layer before we compact to be about 4 to 6 inches. You don't want to fill the entire depth at once because you won't be able to, get those bottom few inches compact enough so that they won't settle out over time. They won't settle down over time. And a question we get a lot, and it's a really important one, is how thick do we want, or deep do we want our aggregate surface trails to be? Personally, I often see projects where, you're seeing the absolute minimum 2, 3, 5, 6 inches of aggregate on an aggregate surface trail. And they generally need maintenance within a few years. You start to see that fabric popping up through as things move. And so we generally shoot for a minimum of 8 to 12 inches of thickness total. And between your base and your surfacing layers, that's excluding your subbase. And we often exceed that. We're often at 14 to 16 inches. And that a lot of that depends on the depth of your organic soil, and how much you need to build up, how much height you need to build up to get proper drainage given the terrain restrictions that you have. There we go. So as we compact in our lifts, we just want to talk about the methods that we use to compact really quickly. These are typical compactors that we see on the left. The one in the foreground's a lightweight plate compactor, a vibratory plate compactor. It works with vibration. The one right behind it is a double drum vibratory roller. And so the plate compactor can get into tighter places, but the drum roller is much faster and does a better job compacting drier aggregate than the plate compactor does. If you're ever running a plate compactor and the aggregate's so dry that you're seeing dust clouds come up, you're losing all of the fines, which are essential to be the binder in your aggregate layer, and you're doing yourself a disservice. We'll talk about that a little bit more in a second. We sometimes also use heavier plate compactors that have forward and reverse motion. So particularly with your final compaction, but also with your, with each tier you compact, moisture is essential. It creates, water creates that ionic charge that attracts particles together. It's essential to have stuff stick. And you need it to stick together instead of displacing in order to achieve your compaction rates. So that can be tricky sometimes. We often end up leaving a compactor or two on site even after we demobilize from a project, so that we wait until those rainstorms happen, those nice soaking gentle rains, and go and compact after that. As Aaron alluded to, you don't want to compact when it's too wet either. If you're ever using a plate compactor and you're starting to see like the surface turn into mud, or stuff starting to bubble up, it's too wet to compact, you're also doing yourself a disservice. So you want to try to hit that sweet spot. And sometimes nature's not conducive to our construction deadlines, and so we have to augment with water that we bring in. So this picture actually, we were pumping water from a nearby pond and bringing it in, and putting it in a vehicle, and actually adding water that way in order to get our compaction rates to what we needed to be. And so our top coat, or our surfacing layer, I think as Aaron labeled it earlier in the slide, is the next thing that we add if needed. And so we generally install a top coat of a slightly different aggregate when we're building accessible trails. And so I guess I kind of glossed over what we were using for our base aggregate. We generally use a 3/4 inch minus gravel. That's processed as like Aaron was talking about. And that will be our base. So this picture on the left, you can see that's that brown 3/4 inch minus gravel that we used as our base. And then we're top coating it with a surfacing matrix that's usually 3/8 inch minus. We have some sort of specific recipes that we prefer to use for accessible trails that work really well. But that changes with where you are geographically and what you have access to in terms of quarries and how far you can truck stuff. So it's I'm not going to make any specific claims of exactly what should be used or what shouldn't, but your top coat's the last thing to go on if you're doing an accessible trail. Usually that top coat wants to be 2 to 4 inches thick, and so that's a really good thickness. You can go a little heavier, you can go a little lighter, but usually we shoot for that 2 to 4 inches of thickness for our top coat. And again, just a nice shot of needing the moisture to compact. Next, we finish our edges and we naturalize. And this is a step that is very time and labor consuming, and adds to the cost of a trail significantly, but it's critical to not only aesthetics, but the function of how a trail works. Just throwing gravel on the ground is not going to allow water to move across it the way we need it to. So what we do is we hand finish the edges when we naturalize. And if you see on the picture on the right, the guy who's in the red, if you look at his feet, if you imagine water coming down onto the trail from above, what's it going to do there? It's going to puddle right behind his heels and eventually probably push through the trail. And then likewise on the downhill side of the trail, it's not going to move across the landscape in a sheet flow the way we'd like it to. But if you look behind the guy in the green, where after they've finished that and hand compacted those edges and naturalizing it, visualize how the water will move across the landscape over the trail and off the trail. It makes it a much more stable surface. The water continues to stay in a sheet flow. It moves from over the trail, off the trail, with minimal, if any, soil migration, aggregate migration. Then we stabilize. our soils, sometimes seeding and mulching. We don't always have to seed and mulch, depending on where we are. And some clients don't want to import any seed source at all. And sometimes there's plenty of seed source in what we have for excavated organic on the edges. But as needed, we stabilize our soils, we seed, we mulch. We basically, anything that we disturb, we stabilize. We try to stabilize that day, if not that day, certainly before any rain events. So that's it for the construction piece. We'll get into a little bit of some of the more common maintenance issues and things you can plan on if you're going to construct an aggregate trail.
Wonderful. Thanks, Jen. So I think a lot of times there's this maybe illusion that aggregate surface trails don't need maintenance. But like I said, that's just an illusion. They do require maintenance. And we're going to go through a couple of slides that are, typical things that we see on a trail. And the main one is like that clearing and cleaning. So this involves removing like the debris, fallen branches, and some of that leaf litter. Do be careful when you use a leaf blower because you don't want to remove all those fines. So essentially you can just turn on the leaf blower. You don't need any throttle and just let those leaves get blown off the trail without removing any fines. So you're not going to want to do it when the trail's too dry. And then be careful that you don't create a berm along the edge of the trail when you do leaf blow and clean that trail. Next slide, please, Jen. Thank you. So this is the same trail. The picture on the left is just after construction, and the picture on the right, I believe, is a year later. But it just shows how much that vegetation can grow into the trail. Next slide, please, Jen. I think there's two here.
Yeah.
So vegetation management is really key to maintaining that trail's width, reducing some obstacles, and preventing erosion that is caused by that unchecked plant growth. If you end up mowing next to a trail, try to blow the clippings away. Oftentimes what you'll see is someone just barreling down the edge, and all that grass clippings and those seeds make its way into the tread surface, and then eventually it ends up growing. Next slide, please. And another common one we tend to see, this was a rebuild of an accessible trail. I'm not sure who constructed it, but is that deberming and reprofiling. So that deberming involves removing excess material that forms that berm along the trail, very similar that we see when we get like cup trails. So we want to make sure that we deberm it and we reprofile so that we're maintaining that outslope treadway or crown treadway or inslope treadway. So we're ensuring that proper sheet flow of water.
Great. Thanks, Aaron. And then we get this question a lot of like, once we build a trail, like how much maintenance are we going to need, And so I think Aaron highlighted a lot of the annual stuff that you would have to do, or sometimes some of that vegetation maintenance would be mowing multiple times a season. Occasionally we need to regrade depending on the trail. When we do that, there's a variety of ways to do it. You can use a power box rake like we talked about. This is simply a trail. It's a cross-country ski trail that we utilizing native soils or native aggregate. We're on a sort of an esker, a gravel area. Where we ran a York rake over it behind a piece of equipment. So that works really well. Simple regrading annually can do a lot. Over time, just like we regrade our roads. Over time, every few years, sometimes 5, sometimes 10, depending on location, use, and watershed, you'll need to resurface your trails. And generally, it's a pretty straightforward process where you just come in with generally smaller machines than the width of the trail, and then add anywhere from 1 inch to 3 inches of material of aggregate and recompact, reprofile like Aaron was talking about, get your crown or your outslope, make sure your drainage is happening. But generally that can go pretty quickly. This picture on the left, I think we, on it with a 2-person crew, we're averaging 1,000 to 1,500 feet of resurfacing a day. And then before compacting, with compacting went really quickly also. And then as much as we would love to say we build trails perfectly the first time we analyze the drainage, the watersheds exactly the way we anticipated, you're going to probably have to go back and do some stuff. Puddles and blowouts are pretty common. Finding places that don't shed water the way we expected them to is an unfortunate reality. And so, the picture on the left was we were able to take care of that simply by doing some off-trail ditching and swales. So by getting the water off the trail, took some considerable work off trail, which is something we actually do a lot in order to manage the water on the trail. We have to ditch it off the trail, and then refilling it. The middle picture took a little bit more. We had to install more gravel, get the height of there, but there was no real place to drain the trail here. So we had to install a timber box culvert to allow for lateral flow, and then build up about 12 inches of tread. And then that stayed high and dry since. The picture on the right is simply a spot where there was no evidence of water coming onto the trail. And then we got a major rain event, and blowouts like that do occasionally happen. And then you have to go back and really analyze. If you have a trail that has a number of these blowouts, my recommendation is to try to get a professional to come by and give a comprehensive maintenance plan for that trail, because it's probably going to take more than just throwing the same amount of gravel back down and watching it wash away in the next storm. Sometimes that involves some modification and retrofitting, like I was talking about, adding box culverts. This is an example of a trail where we built the trail and then they actually changed the parking lot, and so after we left, the parking lot started shedding water. We had to get the water across the trail. It was a new influx. The same thing can happen with harvesting or logging operations after you construct a trail. Hydrology is dynamic and it moves, things change. Water changes the way it moves across the landscape pretty frequently. So now we have got a little bit of time. How are we doing, Aaron? We've got a few examples of aggregate surface trails. We can just gloss over them really quickly to get to a Q&A.
Yeah, that'd be great. There's a lot of questions.
Okay.
We have 12 minutes.
We have 12 minutes left.
Yes.
All right. Well, how about we just go through photos and mention the projects really quickly, and then get to questions, 10 minutes of questions?
Perfect.
Okay. This is an example of a trail that was built at Togogo Bimick Visitor Center at Katahdin Area Woods and Waters in Maine that we constructed. It was, just keep flipping through.
This trail had high use. It was a connector trail, and it's very popular year-round.
And we had little lessons for each of these trails, but we're skipping over them for the sake of Q&A. Here's a project we built, about 7 miles of gravel surface multi-use trail around a couple mountains in Camden on the mid-coast of Maine. We learned a lot about watershed in that project.
And then this project had inadequate subgrade, so I used fabric, angular stone fabrics in a surfacing matrix. It was a very short section and pretty remote.
We were talking about building over ledge. This is a trail that was sort of circumnavigates the summit of a big granite dome, Mount Agmenticus in York, Maine. And so we're basically building over ledge the entire time. So we had to build up with a lot of walls and put a lot of crush in, remove a lot of ledge in order to get the trail in.
This is an accessible trail through a blueberry field. So I use the aggregate surface to create that firm and stable surface.
This one's a little bit different. It's actually a green cemetery or conservation burial ground. So this is a fully accessible trail with actually grave sites all around that people basically going for a walk in the woods, and there's no visual headstones.
This is a brand new trail on 1,400 acres in Hancock, Maine. The aggregate surfacing is only at the entrances, the 2 different entrances to the trail, to deal with subterranean drainage as it moves through the landscape.
And this is a an interesting trail because it's part of an art tour, and this is it meanders sort of whimsically around and through a bunch of sculptures done by the artist Bernard Langley in Mid-Coast, Maine. It kind of just shows how we can affect the user experience in sort of a whimsical way with these trails.
And this is a project that Jen and I partnered on this year at Mount Major. It had no soil and very high use.
All right. So again, we had lessons on each one of those, but we want to get to your questions. I think it's really important. But I'll just talk about some key takeaways before I get to the questions. It's all, if you haven't figured it out, it's about drainage and compaction. Figure out where your water's flowing, where it needs to flow. Really focus on that. Water can blow out the best built aggregate surface trail very, very quickly. Source the best surfacing matrix available to you. Know that value of hand finishing because it really does affect the way that your trail sheds water over time. Utilize the proper equipment. Beware your shoulder seasons. Try not to build too early in the spring or too late in the fall, if at all possible, with gravel surface trails. And if you go into it planning on maintenance, don't think that they're maintenance-free trails. You could drastically reduce the amount of maintenance that's needed, but you've got to do stuff every year.
Awesome. Thank you guys so much. Yeah, there's a lot of questions. So there's quite a few asking about when you're doing aggregate surface trails for different users, and if there's specific practices or construction techniques that you use for specifically equestrian and then motorized were two of the questions, or a lot of the questions.
Okay. I'm going to stop sharing, Candace. All right. You have a slide to pull up?
Yep. I'm going to pull it up right now.
Okay. Do you want to take that, Erin?
Sure. So I think a lot about that resistance to mechanical wear and your use, because with those two types of trails, you're going to have, that heavier surface contact area in equestrian trails. And then on some of your other trails, you're going to have that more traffic or faster braking speeds. So there are some guidelines, there are some resources you can pull up for using those different size aggregates. Generally speaking, you're probably going to be looking at a larger size aggregate mixture than you would say for like an accessible trail.
Great. So then there was also quite a lot of questions about accessible trails. And if there's I know Jed touched on this a bit in terms of that top layer, but is it to a standard? Is it based on the land manager? Just kind of how does that work?
Yeah, there's a standard for what that top coat needs to be, and it has to be a firm and stable surface. And there's a whole series of criteria that you need to achieve in order to have compliance with accessibility guidelines. Although half-inch minus aggregate is permissible, we generally go 3/8 inch minus. So 3/8 inch, like the largest aggregate in that surfacing matrix, with that mix that goes on the top, we'll be able to go through a 3/8 inch hole in a screen. That's the size that we shoot for down to stone dust. But you need that 3/8, and you need the stone dust and everything in between, getting at what Erin was talking about with those sieve analysis. And there's a whole slew of other criteria that we have to meet as well. But we're generally going with a finer top coat with accessible trails than we would if we were going with a regular, if it was just a bike trail, for instance, would probably go with 3/4 inch minus gravel as the top surface.
And then the other thing, if you don't mind, I'd like to add in there is that making sure that you do have, like Jed's mentioned, some of those larger particle size. Like you don't want to just top coat with stone dust, because that's going to move around on you with that wind and that sun. If it dries out too much, or if it's too wet, can move pretty easily because those particles are so fine. So you do want that good matrix of that 3/8 inch minus mix.
Absolutely. We actually sometimes will get we will add more of our 3/8 inch rock if we don't like what we were getting from the quarry. We've actually had projects where we've custom mixed up to 5 different types of aggregate that come from the quarry in order to achieve the matrix that we think works best. You need to add those binders, you need the fines, you need that angular 3/8. And so sometimes we're really mixing stuff together to find something that works really, really well. It's a little bit of an art form as well as a science.
There was a question, just can you hand compact aggregate trails? Erin, I'll ask you. Sorry, I'll direct it.
Sure. I mean, yeah, of course you can. I don't know if you're going to get the required compaction that you need for some trail applications. So you can go ahead and, do it. But if you're building like an accessible trail, you're going to want to mechanically compact that, so you get that technical requirement of that firm and stable surface.
Great.
And I'll just piggyback on that. Nature does a great job compacting. If you have an environment, if you're installing aggregate that compacts well, and you have a series of cycles of a soaking rain and then it dries out, and a soaking rain and then it dries out, a soaking rain and dries out, while people are not using it. So it is possible to really use nature to compact your trails, but you got to keep the people off it in the meantime, and it might take some time. So it certainly is possible, but not necessarily ideal.
There is also a question about how steep is too steep for an aggregate surface trail. I know Erin referenced the half rule, but what do you think is kind of that max grade, or is it totally site specific? Erin.
I think thanks, sir. So I think the way that I look at this is I go back to those sustainable trail layout and design principles, and I think about slope and grade and trail slope alignment. And, above what certain grade are we starting to look at structures and the need for structures? And if we're approaching that, then we're probably going to want to stay away from using aggregate without having some other type of rock armoring or stairs or something along those lines.
Great.
Yeah, I agree completely. And I think also if you look at accessibility guidelines, you don't have to make all of your trails built to accessibility guidelines. But if you look at the slopes that are specified in there, they're specified because it's sustainable for humans and also for the material that you're bringing onto the landscape. So once you get past that 10% into the 12% range, beyond that, it's really hard to keep aggregate surfaces staying put.
All right, I'm going to do one more question since there's a lot of these, a lot of questions about binders. So Jed, just in terms of like chemical additives or those kinds of additions, kind of what's your thoughts or experience?
Yeah, I've had a bit of experience, not a tremendous amount. We're fortunate that we have compressible soils where we work in the Northeast. And so, but I've done a lot of research. I've talked to a lot of people that have used different chemical binders. And the results are across the board. There's folks on both sides saying it works really, really well and it fails. Talking about polymeric sand, like we installed some this year and it failed in the first rainstorm, and even though it was installed well, because the water was just coming too quickly. And so when you do get failures with that, it's a little harder to fix than if you're just doing natural. So generally, if I'm looking at a binder, I'm looking at trying to incorporate something like clay, something that's natural and it's fine and it's local, and you can add that to the mix. We've even been able to take a very, very thin layer of super fine particles when they're dry and spread them over the top in like maybe an 1/8 of an inch max thickness, and it settles down into that the existing aggregate, and it works really, really well. I would always opt for natural materials before synthetics.
Awesome. Well, thank you both so much. And now I'll hand it over to Candace.
Yeah, thank you both, Aaron and Jed. Really appreciate your time and efforts on this really important and popular topic. So thank you. And the slide that everyone sees will be emailed to everyone. In my follow-up email, the link to the presenters' combined presentation is on there in PDF format. And all of these links are also available and more on the webinar's webpage already. So I encourage you to check that out. And I again want to thank the Professional Trail Builders Association for hosting this webinar, as well as our additional webinar partners that include Washington's Evergreen Coast, iZone Imaging, the Grisberger Fund, 5280 Creative, the Bureau of Land Management, the National Park Service, and the USDA Forest Service. And again, we hope you will consider donating to American Trails to keep these webinars produced weekly and free to all. You can visit americantrails.org/join for membership and donation options. And so also, we hope you'll join us for our next webinar in the Advancing Trails webinar series. And a reminder to subscribe and support American Trails on our YouTube channel at youtube.com/American Trails. And that's where all of the recordings are housed and where we live stream our webinars. So thank you again to everyone for